Polar coordinates replace the concept of x and y with r and theta. R is the radius, a distance we can imagine on the positive x-axis. Theta is thought of as an angle measured counterclockwise from the positive x-axis. You can find these by measuring the radius and its angle. If you know the Cartesian, you can find the polar coordinates by using the Pythagorean theorem for r and finding the angle with arctan. The positive radius is on the positive x-axis and vice versa. Showing a simple polar equation where you either have r or theta shows you that with r, the angle is free to move, and with the angle, theta, r is free to move as well. To illustrate this point, r equals 2 forms a circle with the radius of 2 because the radius is held constant while theta is free to roam from 0 to 2 pi. When graphing polars, there's a large variety of interesting curves we can make with relatively simple equations. The first of these is a cardioid. Cardioids are made anytime both coefficients and the midline and amplitude are the same in magnitude. To graph, first plot regularly on the x and y graph you are used to. Then you can label and plot on the polar curve, and the design should look like this. Secondly, we have a limacon. The limacon equations are when r equals a plus or minus b cosine theta and r equals a plus or minus b sine of theta, where a is greater than 0 and b is also greater than 0. First, just like before, you would create points a, b, c, d, and e on a regular graph. In this case, we have x-intercepts, or poles. This creates a loop, although it is important to note that not all limacons need to have loops. Graphing without a loop would be a limacon with no zeros, or when it can never cross the x-axis on a regular graph, so the radius never turns negative. This makes it look like a sideways egg. Finally, we have the rose. The rose is when r equals a times cosine n theta and r equals a sine n theta, where a does not equal 0 when n is a positive integer. Important details to note with the rose is that when we start plotting on the regular graph, just as we did before, we also see that we have poles. Each time the radius is negative, a new petal begins, and we will see that when we start plotting it as a polar curve.